Hey guys, we're starting a new unit, and the unit's all about logarithms. But before we really get into logarithms, we need to talk about solving just using exponents. So we're going to practice some of our exponent skills, go back over those laws of exponents, and use them to solve some equations today. So first off, let's take a look, and let's take the ones on the left-hand side here, and we're going to simplify them and match them up with ones that equal the same thing on the right-hand side. So let's start here with 2 to the power of 2x. 2 to the power of 2x. Now, I can raise 2 to the power of 2, but we can't really raise 2 to the power of x and get an answer for it. So we have to leave x up there, but I can work out the 2. So we go 2 to the power of 2. Hey, that's 4. So that's 4, not 4x. It's going to be 4 to the power of x. Look at me, already making mistakes. So that 4 to the power of x, hey, that's going to match up all the way down there. What about 5 to the negative 2x? Well, remember what happens when we have a negative exponent. Whenever you see a negative exponent, we flip it inside of a fraction. So I'm going to have to flip this one and make this 1 over 5 to the 2x. And now that I can simplify it, 5 squared is 25, so that's going to be 1 over 25 to the power of x. And hey, that matches up with this one. 4 to the power of 3x, well, 4 to the power of 3 is going to give me 64. So 4 to the power of 3, that is going to be 64 to the power of x. That matches up with this one. Okay, then 2 to the power of 4x. Might be a good chance to get out your calculator, but 2 to the power of 4x is 16 to the power of x. So that one's going to go here. 2 to the negative 5, that one flips again. Remember, negative exponents flip that fraction. So we're going to go 1 over 2 to the power of 5x, which is, of course, going to be 32. So you get 1 over 32 to the power of x. And hey, that guy's up there. All right, now 2 to the power of 6x, that's going to be 64. So we get 64 to the power of x. And that one is right across from us. So we can go to the more than ones on this side. So you can see that this one got us to 64 and this one got us to 64. So you can get there in different ways. All right, 4 to the power of 2x. 4 to the power of 2x is going to be 16x. 16 to the power of x, right? Because 4 squared is, of course, 16. To the power of 5x. That one, of course, is going to be 32 to the power of x, which is right across. And then last one, 2 to the power of 3x. That one's too easy. 8 to the power of x. We kind of have to go searching for that one. It's right up here. So we're just going to go all the way up to 8x to fill in our notes there. So hopefully that gives you some options. As we go through this, you can see, hey, all right, these match up with these, and so on and so forth. All right, so that is some little exponent play that we can use. But now let's break this down. I'm going to show you how we can solve equations using exponents. And to do that, we need to remember some rules of exponents. Remember, if you have the same base, so if like x times x, or in this case, 3 times 3, if you have the same base, you add your exponents, okay? If we are multiplying. If you're multiplying two things together, we add the exponents if it's the same base. If we are dividing the same base, we're going to subtract the exponents. So what I'm going to do here first is I'm going to multiply these two together. I'm going to go 3 times 3. Well, just kidding. It's not going to make 9 because we have the same base. It can just be 3. And we're going to add these two exponents together. So we're going to have n plus 2 are up there together. And the other side is just going to stay the same. Now, here's the big deal. If you have two bases that are the same and they're set equal to each other, the exponents, to make it a true statement, also have to be the same. So that means that this n plus 2 and this 8 also have to be the same. So what we can do is we can set them equal to each other and solve. I can go n plus 2 equals 8, and I can solve this. I can just minus 2 to both sides and get n equals 6. So long story short, what we're trying to do is we're trying to get things to where it's one simplified base of the same on one side, one simplified base of the same number on the other side, And that way we can set our exponents equal to each other and solve a simple equation like that. Let me show you again on number 2. So number 2 here, similar type equation, except we are just simplifying by dividing and raising to a power. So remember, when you have a power stacked on a power, we multiply, okay? Whenever we have a power stacked on top of a power, we multiply. So I'm going to distribute this little 4 to both of these guys, and we're going to get 5 to the 4x over 5 to the 3 times 4 is 12 equals 5 squared. Now remember, when we divide two of the same base, we subtract their exponents. So whenever I go 5 divided by 5, we're going to actually just subtract my exponents. So I'm going to go, this is just going to be 5 to the 4x minus 12 equals 5 squared. Okay? And so now what we can do is we can take this exponent here and set it equal to this exponent here. We can go 4x minus 12 equals 2. Now it's just a basic equation that I need to solve. I'm going to add 12 to both sides, get 4x equals 14, divide both sides by 4, get x equals 14 over 4, or to be more accurate, x equals, simplified version, 7 over 2. You could also write it as, what is that, 3.5? You could also write it like that. Doesn't matter. But there's our answer. X equals 7 over 2. All right, so that's what happens whenever we start off and we have multiples of the same base. But what if we start off here where we don't have the same base? This one is 3 and this one is 27. Obviously not the same base. So we're going to try to simplify both these and create the same base. So here we go. 3 to the power of x squared. Well, we're going to multiply that by my exponents. It's going to be 3 to the 2x equals 27 to the x minus 1. Well, let's see if we can make the same base here. If I can make the same base, it'll be a lot easier. So let's take this 27 and let's say, okay, what can this 27 equal that's related to a base of 3? Well, 27 equals 3 to the power of 3, right? 3 cubed equals 27. So that's a great, using your calculator, you can help yourself find the little missing piece to the puzzle here. So that's our missing piece of the puzzle. 27 equals 3 to the power of 3. But we can't forget about this x minus 1. That's going to stay here on the end. We're going to go 3 times x minus 1. So now, I have the same base, so I can take my two exponents and set them equal to each other. I can go 2x equals 3 times x minus 1. So we're going to distribute my 3 times x, 3 times negative 1, and I'm going to get 2x equals 3x minus 3. Let's move this 3x over to the other side. That's going to give me negative x equals negative 3. Divide both sides by negative 1. And we're going to get x equals 3. Okay? All right, so there's our answer to that first problem. We found the same base. We're going to do something very similar on the next one. On the next one, we're going to find the same base here. And we have to think, okay, what base could I find that's the same between 9 and 27? What fits in both? What is a root of both? And it's 3. 3, we're going to have 3 squared equals 9, and 3 cubed equals 27. So I can change this 9 into a 3 squared, but we can't forget about that, so we write in 8 minus x. And 27 can change to 3 to the third, but we can't forget about this x minus 3. So now, take our two things. If we have the same base, we can take our two and set them equal to each other. So I can go 2 times 8 minus x equals 3 times x minus 3. We can distribute, combine like terms, and solve. So we're going to distribute our 2 here. So I'm going to go 2 times 8, 2 times negative x. We're going to 16 minus 2x equals, distribute here, 3x minus 9. Okay, let's get our numbers together. So let us add 2x over to this side. Sorry, wrong spot. Come on, Mr. Martin, get it together. Okay. So add 2x to this side, add 9 here, add 9 here. So these cancel, and I'm going to be left with 5x equals 16 plus 9 is 25. Last step, divide both sides by 5, and we're going to get our answer of x equals 5. I'm going to rewrite it like this, x equals 5. Okay, so then that's going to leave us with, okay. All right, so then we're going to move on to our next problem, number 5. So number 5, we have 3 to the x squared equals 9 to the 8. All right, so we already decided that 9 equals 3 squared, right? So 9 equals 3 squared. So I can replace that 9 with the 3 squared times 8, and that's going to equal 3 times x squared. 2 times 8 is 16, so we're going to have 3 to the 16th equals 3 to the x squared. They have the same base, so we can set our exponents equal to each other. I can go x squared equals 16. Now to solve for x, to get rid of that squared, remember we have to square root both sides. And so we're going to get as our answer x equals the square root of 16 is going to give me plus or minus 4. Remember, 4 times 4, 16. Negative 4 times negative 4, also 16. So whenever we solve those quadratic equations, even if it is a simple one like this, we get 2 answers most of the time, and this time it's 4 and negative 4. All right, number 6. This one's really important, okay? This one, we have to remember something important. We have to remember that a square root of 2 equals 2 to the 1/2. Okay? Square root of 2 equals 2 to the 1/2. The reason that is, remember, a square root, there's a little index right here of 2, and we are raising it to the power over the index. So I can rewrite that square root of 2 as 2 to the 1/2. Then just set my exponents equal to each other, and we just get x equals 1/2, and bing, bang, boom, that's our answer for number 6. Let's look at number 7. So number 7, we have 2 to the x minus 3 equals 1 over 32. All right, so on this one, we get 2 to the x minus 3 equals 1 over 32. Now that 1 over 32, listen, we can rewrite that out, just like we did on that front page. This 1 over, well, first off, 32 equals 2 to the 5th power, okay? So 32 equals 2 to the 5th power. So that's going to leave me with 2 x minus 3 is going to equal 1 over 2 to the 5th power. And so we're almost the same. However, this is still a fraction, and I want it to just be my base and my exponent. So to get us backwards, we need to be able to flip this fraction. Remember, to do that, we need a negative exponent. So we're going to change this to be 2 times x minus 3 equals 2 to the negative 5. I have a little remember section up here. Remember, moving an exponent after the fraction bar changes the sign. So if I wanted to flip it to the top, we would change it to a negative 5. Now, I have the same base, and we can just set our exponents equal to 0. So I can go this x minus 3 and this negative 5, set those two equal to each other, solve for x, add 3 to both sides, and we're going to get x equals negative 2. Okay? All right, now, our last one here, we have 49 to the n plus 4 equals 7 to the n over 2. Don't let that fraction freak you out, okay? This 49 equals 7 squared, okay? 7 squared equals 49. So I can replace that 49 with 7 squared, multiply it by n plus 4, okay? So now, same base, take our two things, set them equal to each other, okay? So we go 2 times n plus 4 equals n over 2. I can distribute my 2 here, go 2 times n, 2 times 4. I get 2n plus 8 equals n over 2. Now I want to clear out my fraction, okay? So I want to clear out my fraction. To clear out my fraction, I'm going to multiply this side by 2, cancel it out. But that means I'm also going to multiply this side, the whole side, by 2. So we're going to get 2 times 2n is 4n. 2 times 8 is 16, so we get 4n plus 16 equals n. I can then minus 3n to both sides. Get 16 equals negative 2n. And then we can just divide, actually, sorry, not minus 3n. Silly. I was thinking about what the answer was going to be, and then I wrote the wrong answer. That is just a classic Mr. Martin move. I'm going to minus 4n to this side, minus 4n to this side. That's going to give me negative 3n. Then we're going to divide both sides by negative 3 to get my final answer of n equals negative 16 over 3. And that's my solution. Okay? So remember, what we're trying to do is finagle our way to have the same base. Once we have the same base, we can set my exponents equal. As always, if you have any questions, be sure to let